everyone. This video would focus on graphing sideways parabola, or in quotation, sleeping parabola in vertex or graphing form. And this is the third part. In this part, our absolute value for A is greater than 1. Before we go further, please feel free to check out the description below for the link of the other series of topics related to sideways parabola. Before we jump into this example right here, let's have a review on the basics of sideways parabola, or in quotation, sleeping parabola, in vertex form or graphing form. We remember that the vertex form or the graphing form of sideways parabola or sleeping parabola is given in an equation x equals a parentheses y minus k squared plus h. Now let's look at the effects of the parameters a, h, and k to the graph. So this is the graph of a sideways parabola or sleeping parabola. We remember that if A is positive, the parabola opens to the right. As you can see, this graph opens to the right. Now, if A is 0, the graph is a vertical line. On the other hand, if A is negative, the graph opens to the left. On the other hand, we also remember that if the value of A gets closer to 0, the graph becomes vertically stretched. So you can see the graph becomes more and more vertical until up to a point that at 0, it becomes a vertical line. On the other hand as well, if we start from 10, then we go towards 0. We change the value of A towards 0. We can see that the graph again becomes vertically stretched. That means it becomes more and more vertical up to a point that it turns into a vertical line when A is 0. On the contrary, if the value of A gets farther from 0, so right now it's a vertical line. If we go farther from 0 towards the positive 10, the graph becomes horizontally compressed, meaning it becomes more and more horizontal in shape as we go farther from 0. This is also the same thing if we go the other side. So if we start from 0, which is a vertical line, if we go or if we change the value of A away from 0 towards negative 10, the graph becomes horizontally compressed, meaning it becomes more and more horizontal in shape. We also remember that the coordinate HK is the vertex of the graph, or we sometimes call this as the locator point. So this one right here is our locator point. Now we remember that the K is the parameter that translates the graph up or down, while the H is the parameter that translates the graph left or right. Okay, so we go over the problem here. Our first step, in order that we can sketch the graph of this equation that we have right here, is to determine the vertex or the locator point. I'm going to go ahead and write that down here. The coordinate of the vertex or locator point is HK. For a sleeping parabola, this will be our H and this will be our K. So to write this, that's going to be keep the sign of the H, that's 6, and switch the sign of the K, that's negative 3. So this is where our vertex is going to sit. The second step is to create and complete the table of values. I'm going to go ahead and draw the table of values down here. Okay, our vertex is going to sit in the middle of the table right here. So this will be 6 and negative 3. Now we are going to complete the values for the y here, since we have the x that's missing. So it's the y that we complete. So I can go ahead and say this is negative 4 and negative 5. I can go up to negative 2 and negative 1. Our next task is to determine the value of x. So what are we going to do is we are going to use the value of y that we have right here and we plug it into the equation and solve for x. So let's say our y is negative 2. So what we would do is we're going to rewrite this equation, but instead of y, we're going to put in the negative 2. So this is how the equation is going to look like. Okay, so I put in negative 2 to the y, and then we're going to do the math for this. So this would come out negative 2, and then negative 2 plus 3 is positive 1, and then squared plus 6. And so this comes out negative 2. 1 squared is 1 plus 6. So this comes out negative 2 plus 6 is positive 4. So our answer here is positive 4. Now let's see what is the x value when the y is negative 4. I'm going to show the work on the side right here. Okay, so what's going on here was that we have negative 4 plus 3 is negative 1. When we square the negative 1, it comes out positive 1 because that means negative 1 times negative 1 is a positive 1. So positive 1 times negative 2 is negative 2 plus 6 is 4. So I'm going to go ahead and write 4 down here. And so I'm going to show the work for the value of x when y is negative 1 and the value of x when y is negative 5 down here. Okay, so our value here is negative 2 for both of them. Now, please notice this very carefully. We have a negative 5 plus 3 is negative 2. Again, remember, negative 2 squared means negative 2 times negative 2. That comes out positive 4. And so we got a negative 8 because we have a negative 2 times 4 is negative 8 plus 6 is negative 2. Our next task is to sketch the graph. So we're going to start with the vertex. It's 6 and negative 3. So 6 right here, and we go down 3. So that's the first dot. We have 4 and negative 4. So that's going to be 4. Then we go down to negative 4. So it's going to sit right here. So we have negative 2 goes with negative 5. So this is where it's going to sit. And then we have positive 4 goes with negative 2. So it's going to sit right here. And then negative 2 goes with negative 1, so it's going to sit here. And so we go ahead and sketch the graph. So this is the graph of this equation that we have right here. Please notice that our domain here would be the x values that are less than or equal to 6. So going to the left. And this graph is going up towards the infinity and going down towards infinity. And so the range would be all real numbers. Now, please remember that this kind of graph is not a function, because if we use the horizontal line test, it's going to touch the pencil twice. And so this is not a function. So I'm going to go ahead and write those information up here. Okay, now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So the first step is to determine the locator point or the vertex. I'm going to go ahead and write that down here. Okay, our vertex or locator point is located on HK. So this is our H, this is our K. We keep the H, that's negative 5. We switch the K, that's going to be a positive 1. And so we go ahead and move on to the second step, create and complete the table of values. So I'm going to go ahead and write the table of values down here. Okay, what we do is we fill in the values for y. So we can go ahead and go up to 2 and then 3, then go down to 0 and negative 1. Our next task is to determine the value of x using this equation by plugging in the value of y into the equation. So I'm going to go ahead and show that work on the side right here. Okay, now please notice this very carefully. For this side right here, we have a negative. All the rest here, we're good because we got a positive inside the parentheses. Now, here's the thing for the ones with negative inside the parentheses. So we got a negative 1 and negative 2. Remember, this is squared. This means that this is negative 1 times negative 1. It will come out a positive 1. And so we did the math. That's x equals negative 2. Well, in here, we have a negative 2 times negative 2 is a positive 4. And so we go ahead and 3 times 4 is 12 minus 5 is positive 7. And so we go ahead and fill that in here. So we're now ready to move on to the last step, which is to sketch the graph. So we're going to start with the vertex -5 and 1. So -5 goes up to 1. So that's the vertex right there. We have a -2, so -1, -2, and goes to +2. So it's going to sit right here. And then we have a +7. So 7 is all the way up here. And then it goes with 3. So it's going to get paired up to the 3 up here. And then we have a -2 pairs up with 0. So this is the next dot. And then +7 pairs up with -1. So this is where it's going to sit. And so we're now ready to sketch the graph. You can see that this type of graph is not a function, again, because if we test using the vertical line test, the graph is going to touch the pencil twice. So this is not a function. And the domain for this would be the numbers that are greater than or equal to -5. So that means from -5 all the way to the right would be our domain values. While the range here would be all real numbers, because this graph is going to go towards infinity upward and downward towards infinity. And so I'm going to go ahead and write those information up here. Did you get the same answers as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!